You are standing at the edge of a cliff. You look down. You cannot see the bottom. Now imagine that cliff has no bottom at all. That is what a black hole is. Not a hole in space. A place where space itself stops behaving like space. And the strange part is, if you fell into one, the last thing you would feel is normal. Your brain is built to trust its senses. It tells you the ground is solid. It tells you time moves forward at the same speed for everyone. Near a black hole, none of that is true anymore. But the real answer to what happens to you is far stranger than any horror movie has ever shown. Let's start with the edge. Scientists call it the event horizon. Sounds complicated. It just means the point of no return. Past this line, nothing escapes. Not light, not sound, not you. Here is the first shock. You would not feel yourself crossing it. No flash, no wall, no warning siren in your ear. You would drift across the event horizon of a large enough black hole and notice nothing unusual at all. Your body would keep floating. Your heart would keep beating. The stars behind you would still twinkle for a little while longer. This is one of the strangest facts in physics. Crossing the point of no return feels like crossing nothing. But someone watching you from far away would see something completely different. To them, you would slow down, slower and slower. Your image would freeze at the edge, glowing fainter and fainter until it faded from view entirely. They would never actually see you fall in. You would just seem to hang there forever, trapped in the last frozen second before the horizon. Two people, one event, two completely different stories. Whose version is real? Both are. That is the part your brain refuses to accept. This comes down to something Albert Einstein worked out over a century ago, and that physicist Kip Thorne spent decades applying to real black holes. Gravity does not just pull on objects, it bends time itself. The stronger the gravity, the slower time moves for anyone nearby. Near a black hole, gravity is not just strong. It is extreme enough to almost stop time completely at the edge. So from your point of view, you fall in normally. From the universe's point of view, you never quite finish falling. You become a kind of ghost, frozen in the last light you ever emit. Now let's go deeper, literally. As you keep falling past the horizon, gravity does not treat your whole body equally. Your feet, closer to the black hole's center, get pulled harder than your head. The difference is small at first, then it isn't. Physicists have a name for what comes next, and it is not subtle. They call it spaghettification. Your body stretches, longer, thinner. The pull on your feet becomes so much stronger than the pull on your head that you are torn apart, atom by atom, into a long, thin stream of matter. For a supermassive black hole, this might take minutes. For a smaller one, it would happen before you even noticed you were falling. Here's the twist almost nobody expects. Bigger black holes are actually gentler. A small black hole has intense gravity concentrated in a tiny space, so the stretching force is brutal and immediate. A supermassive black hole, the kind sitting at the center of most galaxies, spreads its mass across a much larger horizon. Falling into one of those, you could cross the event horizon comfortably, feeling almost nothing unusual before the stretching even began. Comfortable. Falling into an object that eats light. Let that sit for a second. So what happens once you are inside? This is where even the equations start to break down. At the very center of a black hole, according to Einstein's equations, lies something called a singularity, a point where matter is crushed into infinite density and the laws of physics as we understand them simply stop giving useful answers. Mathematician and physicist Roger Penrose proved in the 1960s that this is not just theoretical nonsense. Given the right conditions, singularities are a mathematical certainty, not a strange exception. He won the Nobel Prize for that proof decades later. Nature does not just allow black holes. It guarantees that if enough matter collapses, a singularity must form. Nobody knows what actually happens at that point. Space and time as concepts may not even apply there. It could be the true edge of physics itself. the place where our best theories run out of road. But here is where the story gets even weirder, because of something Stephen Hawking discovered decades after black holes were first predicted. Hawking realized that black holes are not perfectly black after all. Through a strange quantum effect at the very edge of the event horizon, they slowly leak radiation and lose mass over unimaginably long timescales. Given enough time, longer than the current age of the universe by an almost incomprehensible margin, a black hole would eventually evaporate completely. This created one of the most famous unsolved puzzles in modern physics. If a black hole eventually vanishes, what happens to everything and everyone that ever fell into it? Does the information about you simply disappear from the universe forever? That single question, first raised by Hawking and expanded by physicists like Jacob Bekenstein, who showed that black holes carry a kind of entropy just like any other object, is still being argued about by the smartest people alive today. Nobody fully agrees on the answer. Some believe the information gets scrambled and released in the radiation. Some believe it is preserved in ways we cannot yet detect. Some believe our equations are simply incomplete. A black hole is not just a monster that swallows starlight. It is a genuine crack in human knowledge. One of the very few places where the universe openly admits it has secrets we have not earned yet. So why does any of this matter to you, sitting here, not anywhere near a black hole? Because you already know this feeling. Not the stretching, not the crushing gravity. The other part. The part where the closer you get to something unknown, the less certain your own experience becomes. Think about the last time you faced something you couldn't predict, a decision with no clear outcome, a relationship changing shape, a version of your future you couldn't quite picture. From the outside, other people saw you handling it, moving forward, one day at a time. From the inside, it might have felt like time slowed to a crawl, like you were frozen at the edge of something, unable to tell if you had already crossed a line you could not uncross. That is the event horizon of being human. You rarely know exactly when you've passed the point of no return. You just look back later and realize the person watching you from before would never quite recognize who you became on the other side. The universe does not need a black hole to remind you that some transformations only make sense in hindsight. You have already lived a version of this. And somewhere out there, drifting silently in the dark between galaxies, an object with no bottom is still waiting to show anyone brave enough to look what a true point of no return actually means. You looked down at that cliff at the very beginning. Now you know the truth. The scariest part was never the fall. It was that you would never feel yourself crossing the edge.